Okay, let's look at making variables and using variables in Octave. And it's probably one of its most powerful features. You can assign a number to a variable. This would be like assigning a number to a memory location on your calculator, and then reuse that number, recall that by the variable name. So let's see. MATLAB supports different types of numbers. The two most common ones we'll be using are floating point numbers. These are actually stored in called double precision numbers, and this is the default in Octave. And then the other type of data type that we'll be using are characters, are strings, and strings are enclosed within single quotes in MATLAB. In Octave, you can actually use either single quotes or double quotes. Octave does support other data types, complex numbers, symbolic variables, 6-bit and 8-bit integers, and we'll look at some of these others later on in this short course. To create a variable name, you simply just type in the variable name and then assign a value to it. Here, so we're declaring var1 to be equal to 3.14 and my string to be equal to hello world. Notice that the string needs to be enclosed within single quotes. So just repeating that here at the command line. I generally like to use space before and after my equal sign. Notice here that if I type this, I see it displayed. Now if I end the line with a semicolon, it doesn't display the result. The assignment still takes place. It's just that the result is not displayed. And so this is often used, particularly in scripts, if you just want to see the final result of the script and not all the individual assignments. So again, this just a semicolon at the end of the line just displays, suppresses the standard output of the line. And then was the other one? My string is equal to hello world. Actually, I'll use the single quotes because that's what MATLAB supports. And again, if I put a semicolon here, it suppresses the display, but the variable is assigned. And again, I can just recall a previous variable, or I can do calculations, with this var1 times 2, or I can actually assign that now to another variable. var2 is var1 times 2. And then now I've got an assignment to var2. var3 is var2 plus 12. Again, I'll suppress the normal display, but we'll see that var3 is assigned to over here in the workspace window. I'll see all of the variables that I've defined here. And then actually I can double click them and it'll open them up in the variable editor, but we won't be doing that much. But I can see the type. Start string is a character string and has this. It shows actually it's a 1x20 character array. It actually has 20 elements in it. And var1 is a 1x1 matrix, which is essentially a scalar. Variable names are case sensitive, so var1 is a different thing than var2. I can actually make assignments to both. There are some built-in variables. I is the square root of -1, as is j. Pi is available. E is available. Okay. Infinity is available. Actually, not a number is available. It's useful sometimes for assigning missing values into data sets. What else? Oh, and then answer is a special case. For any sort of calculation I do, that value is assigned to the default variable answer, and then I can reuse answer like multiply it by 2, but then now this is going to redefine answer, and I've got a new answer after every line. Now I can actually save, whoops, save that value, and answer isn't changed, but now I've saved answer. So it's kind of a answer is always the result of the last command executed. Again, quickly give a value, a variable. We can use that once it's defined. We can use that in other calculations. Again, to suppress the output, just end the line with a semicolon. Octave has its default object is a matrix of number. It also supports what's called a cell array, and then also a struct, another data type. We'll be working primarily with matrices here initially. To define a set of values to a matrix, just enclose the matrix in square brackets, and then you can separate the elements by spaces or by commas, and then you would separate rows in a matrix by semicolons. So I'm just actually going to copy and paste this right into my MATLAB window. And then now I've got row defined here as this 4-element vector that contains the number 1, 2, 5.4, and negative 6.6. If I come over here and find row, I'll see it's a 1x4 matrix. I can get access to any of the elements. This is the second element in this row vector, or I can even redefine a particular element in that matrix. And again, I can recall that at any time. I defined a row matrix. There's a couple different ways to actually define a column matrix. Let me go back to, I can actually separate each number by, put a semicolon after every number, and then this will start a new row. So this will give me a column matrix. The other way to form a column matrix or a column vector is actually just type it in as a row vector, 1, 2, 3, 4, and then just take the transpose of it. We take the transpose with just a single quote, and then that transposes the row vector. I find this a convenient way to create a column vector. It's a lot easier than typing in all of the semicolons. But actually notice our row and col now. Row is 1x4, but if we go find col, it's a 4x1 matrix. And again, I can find any of the elements of this column vector. A col 3 would be the third element, which is also a 3 here. Okay. So you can tell the difference between a row and column vector by looking in the workspace or actually displaying it. The other thing that's useful is I can use the size command to get the size of any variable. Let's see, I think I've got var1 here defined, which is a 1x1. So this is the size function is particularly useful in scripts for determining the number of rows or number of columns in a particular in a particular matrix. There's also the length function, which will give you the maximum dimension of the matrix. So the length of row would just say it's 4, and then I get the same for the column vector that I've created. But you can make matrices here of any size, limited only by the amount of memory in your computer. And here's a 2x2 matrix. So we'll go back into the Octave window. 1 space 2 semicolon, and so then I can type in the elements of the second row. Again, here I can get this in the first row, the element in the second column, okay, or the 2 element, okay, by typing in using double subscripts now to access any of the elements of the matrix. I can also again reassign, make that a 5 to actually change that particular element in the matrix. You can also even stack rows and matrices. They have to be of the right dimension. So, for example, I've got A here. I can define B to be within brackets, A next to A, and notice I get this corresponding B vector. Or I could even do something like A, and then underneath it, I've got now my previous value of B. So A next to A would actually be, a 2x4, and then stacking this new row under it, this B has to have the same number of columns. So then I can expand B like that. So there's lots of neat little things you can do with. This is very much like using block matrices, as we covered in our linear algebra portion of our course. Let me go back here. So this shows some different ways for doing that. I will note here too, the other way to actually, this is called string concatenation in Octave. Or MATLAB, the way I do that is within square brackets. I can put 2 strings and this will form one long string. And notice in this case, I didn't leave a space. If I wanted a space, I actually have to leave a space before hello, before world, or after hello to get the actual space as part of the string. But string now is one long string formed by concatenating these 2 shorter strings together. Okay, and we can treat strings the same way. I can pull out the first element of string. I can get the length of string. I can do I can get the size of string. It's 1x11, or I can even reassign to any particular element in the string character array. The other thing that we can do, I tend not to use this feature a lot or very much. I don't find much use for it. And I do a lot of Octave programming, but you can actually save variables to a file. It will save them actually to your current directory. So, for example, let's see what file name my file. So I've got this B vector, save my file, and then B, and then you'll see now that we've created a file called my file here that's in this working directory. I can actually use the clear command to clear the workspace, and then now all these previous values that I've defined are no longer available. Sometimes you want to put the clear command at the top of the script to clear out all previous variable definitions. But I've cleared things, so B is not currently defined, but I have saved it previously, so I can load my file. And then now I just saved the variable B. I could put other variables here, but now B is restored just like it was before. And so I can save and load variables to files really easily. And it talks about clearing here. You can clear particular variables and then load them, or we can clear everything with a clear all. So here's a little exercise. How do we get and save the current date and time? Well, there is a clock function. If you call clock, you'll see that, well, it returns, it looks like an array of numbers. This, you can guess, this is the year, the month, the date, the current time, minute and hour, minute and second. Okay, so if we wanted to actually assign that to a variable, we could save those. Now this is going to be a few seconds later than when I called it previously. Um, uh, it's now 53 minutes. This is 8:53 in the evening. I'm currently producing this video. So I've assigned that to a particular value. Um, so you could actually determine the elements of the start string by looking at help clock to see that, to verify that I've identified those correctly. Now you know, this form isn't all that convenient to use. There's another function called date string, where if I pass it a current clock value or a previously stored value, it returns a string, you know, in a little bit more user-friendly or readable format. The 12th of April 2020 at 20:53:16, you know, or I can call this with actually just the clock function as well, and to get the current time. But calling it with start prints out a previously stored date here. So says so we've convert that to a string, use the function, and name the new variable start string. So let me just recall that start string. So now I've got start and the number format, and I've got start string variable in this more human readable format, but they're both actually referring to the same date and time. And then it says save these into a file called start time. So here's how we would do that: save start time, and then start and start string. Okay, so we've done that now, and so we should see a new file over here called start time, which has both of those in it. Okay, and then let's see. So I think we've done this part of the exercise. We've completed all that. This is just showing you the commands to do from the command line, and then now we want to modify our Hello World program to read in the variables we just saved using load, and then display. I started learning MATLAB on that start time date. We'll have to concatenate these two strings. So pause the video here for a few seconds and try to do this on your own. Okay. So here's what that looks like. All you need to do is in your script, in your Hello World script, load start time. Then here's how we actually concatenate, again, the two strings. We have to enclose them in square brackets. Now I saved the time in the start string variable, so I load that back in. Again, I can clear everything out. But if I run Hello World now, it says I started learning Octave on this particular date. I will show you one other thing here, and it's illustrated actually on this slide. There's this dot, 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 which is a continuation, represents a continuation for a long line in the editor. So actually, in this case, in most cases, Octave will just continue automatically if you haven't if you've got an if you haven't closed the bracket or parentheses. Let me try this and see. Actually, here it embedded the new line in the string, but if I put the dot, 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 actually, it means this line continues on the next line, and I could continue this for a very long Octave command line. I could use dot, dot, dot to just continue so that I don't have a long line in my editor. And then, you know, if I run it there, now I see it all as one long line. Okay. So that's it for this video. Next video we'll look at manipulating variables.